development program on artificial intelligence, machine learning applications in power systems. So I hope you have enjoyed previous 2 days and the lectures on artificial intelligence and artificial neural network. So this is third day of this FDP, and we are very privileged to have with us Dr. Rajesh Kumar sir. So I would like to request convener of this FDP, Dr. Ravindra Munje sir, and to please welcome Dr. Rajesh Kumar sir.
Yeah. A very good morning to one and all. I am very happy to introduce our today's speaker, Dr. Rajesh Kumar. Dr. Rajesh Kumar received his BTech degree from NIT Kurukshetra, India, the MTech degree in Power System, and the PhD degree in Intelligent Systems, MNIT Jaipur. He was postdoctoral researcher in the Department of Electrical and Computer Engineering at National University of Singapore from 2009 to 2011. Currently, he has been working as a professor with the Department of Electrical Engineering, MNIT Jaipur. Dr. Kumar research interests focus on intelligent systems, machine intelligence, power management, smart grid, and robotics. Dr. Kumar has published over 500 research articles, has supervised 20 PhD and more than 30 MTech theses. He has 12 patents to his name. He received 3 academic awards, 12 best paper awards, 6 best thesis awards, 4 professional awards, and 25 student awards. He has received the Career Award for Young Teachers in 2002 from Government of India. He is on 12 journal editorial boards. He has been an associate editor of IEEE Access, IEEE ITEN, associate editor Swarm and Evolutionary Computation, elsewhere associate editor for IET Renewable and Power Generation, associate editor IET Power Electronics, associate editor International Journal of Bio-Inspired Computing, CAAI Transactions on Intelligence Technology, IET. Also, Dr. Kumar is a senior member of IEEE, fellow IET, fellow IEI, fellow IET, life member CSI, senior member IEA NG, and life member IST. He was honorary secretary of IET Rajasthan chapter and XCOM IEEE Delhi PES IAS and vice chairman IET Rajasthan subsection. A very impressive profile he has, and it gives me immense pleasure in welcoming him for this session. I hope you will enjoy his session, and please provide feedback at the end of this session. I welcome you, sir.
Okay, thank you very much. Thank you for this webinar. Today we discuss one of the very interesting domain of machine learning, and that is convolutional neural network, and then we'll see how it can be implemented or how it is useful for our various branches of engineering. And I'll happy to take questions at the end of the session. So you please, during my presentation, if you have any queries, note it, and then we will discuss at the end of the session. So I think I am very audible to you all. Hello. Hello. Please give me some kind of indication that yes, I am audible to all.
Yeah, you are audible, sir.
Okay, fine. So again, good morning to all. And CNN is basically a convolutional neural network. And in this session, what we do is we try to understand the philosophy behind it, how it is developed, or what is the logic behind it, and then we will see some kind of applications. Try to understand the problem by using some kind of a numerical explanation, and then I'll try to explain what work we are doing in my research laboratory. So here I have taken few things from various resources, web, research articles, some work in the laboratories, and obviously from internet also. So before jumping into the theory and discussion on the CNN, let's get motivated where it can be used as such. Popularly, people are using. So one of the domain where people are using is in the diagnosis. In medical diagnosis, what we have images, like you can see the images there, and then the images are filtered on various levels, and then our machine is detecting whether some person is suffering from some kind of a disease or not. So images are taken, they filtered, they processed, and then some kind of machine learning or AI algorithm or technique is being used to automate detection. So in healthcare, yes, people talk about that, okay, it should not be purely machine based or something like that. But in any case, if my machine is generating this thing, this will help the doctors to understand the things very fast and in depth, basically. So this one is one area where CNN is being used. The another area is healthcare, where various things are being monitored. You can see various sensors can be placed on the body, and then we can have a heart rate monitoring, we can have our movement monitoring, we can have some other sensors which can give another kind of signals, and then all these signals or images, they are being monitored, and then they are processed by some kind of a machine learning algorithm, and then that algorithm is being used to detect some kind of abnormalities happening there or not. So this one is another very interesting area of healthcare, and where this has a lot of application. The another area is your self-driving cars. So this is what is expected, that yes, the next generation cars are there, which detect the objectives. You can see the objectives there. So you can see the objectives are there. They are automatically detected, and not only objects are being detected, they are like we can estimate what is the distance between your vehicle and that vehicle, and then what is the speed of that particular vehicle, and all those things can be estimated so that your car behave exactly like a self-driving car. So this one is another very interesting area area of interest for electrical, computer, and mechanical people as such, that okay, can we go for a car which are exactly like behave like humans are driving it and something like that. This one is the same application. You can see these are the scan, MRI, brain scans are there. So it's basically again the detection of some kind of tumors and all these things, because these images are very complex, and the detailing required is very minute, and hence if you do the analysis there, it will take a lot of time. There is a limitation on the biology. The doctor side, they are not so good and algorithmic and all that side, so they see the image, and from there they try to find it out, but an automated system can help them. So CNN has a lot of application when we talk about image scanning or medical disease identification and all that. This one is another very interesting area. Many of you are using it at your home. You have Alexa and all those stuffs at your home. So this one is a voice recognition system. So we have on the way we speak, we have analog audio signal which is converted to your digital signal, and then we apply some kind of pattern recognition technique, and then that is fed to your device. So when you ask Alexa something like about the song or the news or some spell or something like that, so it will do some kind of understand your voice, and then accordingly it catch it or search it from any search engine. So you just imagine that in your home there are 5 people, all are having a different sound pitch, all are having a different frequency, sound talking way. Their sound and all these things are different. Still, the device is working very good. So again, it is something very interesting to see that how the pattern recognition techniques are being used there to identify what you want to say, and then how your device is actually reacting to it. This one is another very important important domain where we can apply CNN and machine learning. That is basically auto texting. So we have certain documents, and then we clear that document, and then find out the keywords, and then we extract the information out of it, and then it has a multiple applications. One is auto texting is basically you give some few words, and then it make a sentence, and then it continue with those things and keep on making a story based upon the keywords. It can be something related to your plagiarism detection kind of a software or something like that. It can be a conversion of from one kind of a matter to another kind of a matter. So this one is another very interesting area which is being used in various smart applications, and the backbone is again some machine learning techniques, and CNN can be applied there also. CNN means there's a convolution level. Finance is one of the another area. So a lot of things are related when we talk about the finance. House, right? You can see there's house building. So you have so many things are there: your house expenditure, your credit cards, your bank statements, your purchase, your online transactions, bank to bank transactions, credit card transactions, and all that. It's a complex structure. And then again, then companies are involved there, and they're some kind of a selling and pricing of various products and all these things. So at the backbone, some kind of a smart engines they work, and it can be applicable there also. So just I'm touching various domains where this can be applied, and then we focus on some application to power system or electrical engineering. Also some work which we have done there. This one is again another area. You can see it's a prediction basically. So it's a stock exchange prediction. It can be your wind prediction. For electrical engineering, wind is a very important thing because your production or generation of electricity directly related to the wind speed and all that. And then you want to use in most proper way. So then you must understand that how much is the wind after certain time and all that, so that you can bid into the electricity market and all that stuff. So not only the wind, we need the estimation of wind, we need the estimation of solar, we need the estimation of the load, and when future electric vehicles are also coming, then we need the estimation of the battery, we need the estimation of how many electric vehicles are on the charging station. So things are like that, and this one is a very interesting domain where we can apply convolution neural network. So pricing is one of the structure, but any signal which is something like this, and you want to predict what is going to happen next instant or after 1 hour or after half an hour, yes, we can apply this thing. You'll see how we can apply this to such kind of a problem. Another very interesting area, that is sentiment analysis. So you have images, and then from images can you find out sentiments? Basically it's neutral or happy or surprise or anger or sad. These are the related, these things are related to your person behavior and his mental state, and likewise. And most of time people hesitate to discuss these issues with doctors and all that. So can we have an automated system which can find out some kind of information about what are the sentiments and all these things, and from there can we infer some kind of information? So this one is very interesting area where you can catch various issues of psychology or behavior analysis, or many big companies, they are using it while interviewing a person and all that. So this one is another area where we can apply CNN. This one is something which is nowadays, I think you have seen many videos also, that old movies are being colored and all these things. So it's auto coloring basically. You can see the image one is simple. This one is your black and white image, where this one is converted to you can say colored image, and it is being done by not manually, it is being done by some kind of a programming related to machine learning. So you can see the exactly behave like that if this first image is taken with the colored camera. So this one is auto coloring, and then you can have image auto coloring, you can have movie auto coloring and all those things. So another interesting application which can be done. This one is another very important application. So just I finish with the 2-3 more applications and then we go for something else. This one is there in your mobiles also. So we have things written in a different language, and then you take a pic of it, and then some kind of algorithm, background algorithm works, which convert this image to a readable image. Basically, this one is here. So you understand English language, so this particular language is converted into English transformation so that you can understand it. So there is nothing like a manual conversion. You need not to copy and paste it here. You just take a pic of it, and then the algorithm process it automatically, and then convert your image into your readable image. So this one is again a very interesting application. Another application for the civil engineering people. We have some signals which are coming there, and from those signals we can estimate the earthquake, not only the earthquake, intensity of the earthquake, and even we can estimate the direction it is propagating, what is the amplitude it will go, and after how much time it will reach to a particular place. So if we do that way, then it will be very helpful for us. Basically, you can help people to save their lives using such kind of a technique. So this one is another very interesting application for the civil engineering people, where you can use some kind of estimation technique to predict earthquakes and something like that. Now this one is the whole world is like going for digital marketing. So most of the companies, they invest a lot in it, and you can see the most few common things there. You can have this is common here, Google is there, okay, LinkedIn is there. So they are writing, the Twitter is there. So how they are passing the information on this? See, these engines are, nothing is free here. Why people are writing something on it, how they are behaving, they are making a money. They are using your writing content to predict about your behavior, what your likings, your dislikings. Accordingly, the company invest in it, and a lot of things are going. So that is digital advertising. We are not going to this because the limitation of the time. Otherwise, it's a very interesting topic and area to discuss in a lot. How they are managing the people, basically sitting somewhere else. So digital marketing is another area which is very popular nowadays. Yeah, this one is very important. This one is architecture design, and you can say this one is basically structure or pick of a particular section of a city. So then it's a thermal mapping kind of things. Then how much or your sunlight is available, okay, how to put your solar panels, where to put your solar panels, and then how much money you can save from it. So it is something like, again, the same. There is nothing like doing it manually. You can take the pic, process it, and then map on different platforms, and then you can find out what is the best placement of the panels and all these things, so that you can have a proper designing of proper usage of your money, basically. This one is another area, designing the products. So what are the likings? What are the likings of various age groups? What are the liking, how they like it, what structures they like it, and it is auto designing and auto coloring. So this one is again industry people, they are using it to develop the various products. This one is again engineering. So you can say thermal images are there. So this one is basically nothing but thermal image. So you can see the current is being taken. So there is some kind of a small leakage. Heating is going on. So either you place a sensor and you don't know where to place it, so you can have a thermal image, and from thermal image you can have a auto processing system, which can give you idea that okay, the temperature is increasing, and why it is increasing you can see, you can find it from there. This one is the second picture of electrical engineering. You can see these are the transformer sections. So how the temperature profile is there in various directions, and then you can have the temperature ranges there, and you can develop an automated system which can indicate you that okay, the temperature is there, but it's within the safe limits, and now the temperature is beyond the limits. So the automated system raise an alarm, so that the temperature is increasing beyond the limits. So you shut down the things or take some kind of action. So this one is another application, which is it's like these are being very commonly used. These are basically thermal images of your motors. You can see here. So your motors are running. You have thermal images. You can have of different colors. Okay, not only here, you can inside the thermal images are also there if it is open structure kind of a structure, and from there you can predict it what is safe and what is not safe. Now how to do it? So one way is you put so many sensors and all that, and sometimes sensor also fails and all these things. The second way is you take the image and then you process the image, the smarter way. So if you have image and you want to process it, then what is the method? And the method is basically you can use one of, there are so many machine learning methods. One of them is your convolutional neural network. Yeah, robotics is another very complex algorithm, complex engineering problem where a lot of motion controllers, mechanical parts, humans, and then so many things are going on. So humans are there, lot of mechanical parts are there, they have their controller, and they are doing everything on a human basically. So this one is the most complex and most sensitive application where we need a lot of precision basically. So this one is another domain where things are being used. This one is city designing. So when we go for the expansion of the city, this is one of the thing, like we take images from there, it automatically predict out, okay, what is the green area, where are the already houses are there, what is the route, and all these things, and based upon that it can suggest you various models or the direction, in which direction you can expand the city, and a lot of other factors are also there. But this is something like, intelligent way of doing the thing. So our today's agenda is basically a few things. In most of the application, you'll find images are there. So let's understand in a very simple way that how your computer read an image, and then why we don't means like we know there is a neural network, and it's a very not very new neural network is very common basic element of your AI. So why don't we use fully connected neural network? Fully connected means everything is connected to everywhere. And then what is a convolution neural network, how it works, and then some applications of my laboratory that I'll discuss. So basically, this one is basically one image. You can see a cat is there, and when you take this image through a camera or send this image to computer, it passes through 3 channels basically, that is RGB channels, red, green, and blue, and the computer reads this image like this one. So basically, you can have a size of image, that is how much is the length and breadth of your images, and there are 3 filters basically. Those are known as RGB filters. So all the images are read like this only in computer when you say reading the image in a computer. So we have rows and columns, and we have channels. And then how it read per channel. So this is how computer reads. So you can see on here it's a real image. This one is my real image, and then computer see it like this, a bunch of numbers you can see here. Numbers written in the row and the columns, and you can see there are different value of these numbers. So my computer understands this image like this, and then the next thing is how to take it further from here. So for we engineers and mathematicians, it's very good, like the image is converted into number. Now I can play with the numbers. So the question is why not to go for fully connected? Now this one is fully connected network. Let me explain in a very brief. This one is, these are the basically inputs here. You can see these are the inputs. Okay, so and these are the basically neurons. They are interconnected with each other. This one is input layer, which is connected to the input, and if this and this one is output layer, and in between whatever is there, these are known as the hidden layers. And each layer is having certain kind of neurons. You can see there are neurons there. Fully connected means each neuron is connected to each neuron. And interesting part to see here is when you connect each neuron to each neuron, then we need to see various things here. To make it working, working, I mean to say, if I give an image here that it is a dog and it identify here it is a dog. So to make it that, what we do, we pass the so many images of dog to this network, and finally from here we see what it is recognizing. If there is an error, then the error is taken, and then we modify these connections weights. Basically, weights means how much strong is the connection. Weak connection means it's a less value, and the strong connection means it's a more value. So these weights are updated. So, and this process is known as training. So we do a lot of this thing. And once it is trained, then next time when you send a new image, it identifies very correctly. So this one is very basic of that is very there in the neural network, and I hope neural network is known to everybody. But the important thing here is you to see that if the image is very simple image, you can see 28 by 28 pixels, which is very not very strong or big image, very simple image. You see here that you need to find out, while you're training, you need to update 2352 weights. All these weights, all weights here, these weights we need to modify. And if I go for the good quality image, say when I'm saying medical images and all these things, so here your image is 200 by 200, and in that case you can see how much weights you need to modify. 1,20,000. It's very damn difficult. Like if you do it the other way around, you need some kind of good algorithms to do it. So and if my image is 512 by 512 pixels or something like that, then this number increases just like anything. So now I have a problem. Images are there of different sizes. Number one, in many cases I need very clear, very good images. So if my image size increases, my structure also increases, and in that case my weights to update it, they are very big in number, in lakhs. So it's my algorithm become very bulky. My machine may not able to do so, because this one is for one image, and now to develop a good model, I have to send thousands of images. So thousands of images I'm sending, and every time update of 1,20,000 weights, it become very bulky. So what is the solution to such type of things? So one is you go for GPUs basically. So if you go for GPUs, your cost increases, and the things become costly. Many times it results into processing that way results into overfitting kind of structures. So to address this thing, some more research being done in medical science, and then computer, electrical, electronics engineers, they move into depth of it. They try to find out something very interesting, and that is here basically. So they talk about convolutional neural network, and what is the logic they are putting to the convolutional neural network is that instead of taking the whole thing at a time, can we take the things in a small parts? Okay, and then we connect those things at the end. So that's the basically logic. And why this logic comes into the picture, the reason is very obvious. It comes from this one, that some study that is basically when we talk about the visual cortex also. So the visual cortex take the things in a very small regions first, and then they combine it to understand the whole picture. So it is not like, if we are looking at certain thing, it is not whole image is taken through eyes and then we are recognizing it. No, small segments are taken, and then they are connected somewhere at the end, finally to give us the clear picture that what is the object is. So that is the concept being developed, being taken from here, that instead of taking the whole image, then the next question is how to do it. So how to do it is basically, I'll explain it to you, but there are few things in the CNN. One is convolution layer, ReLU layer, pooling layer, fully connected layer. I'll explain you one by one why these things comes into the picture. So it is basically something like you get past this image and it's a CNN, it will recognize X, and if it is the image is this, it will recognize O. So this one is image identity, object identification, what is being done there. What are the issues? So somebody say, okay, what is big in it? We have these blocks here, and we can put these blocks either 0 or 1. So this, it's empty 0, this one is black, we can say 1, and then we can match it. So if it match, then it is X, and if it is not matching, then it is O, and that there is nothing as such in it. But the issues are there. These are the certain issues. So you can see all these 4 images, this 1, 2, 3, and 4, all are X basically. And you see that here the size reduces, here the size increases, here this one is shifted, here it is a bit rotated, and also there, same with the O. So it is a challenge basically, but all are X. So if I say write X, means it's difficult. If I ask 50 people to write X, you'll find all write in a different form. But when I pass those images, pick off all X's and pass to my computer program, then it must recognize all as X. And now it is challenging because everybody is writing in a different form, and you are recognizing it correctly. So that's basically an issue. So just simple pixel matching or something like that is not a good idea. It's a heavy or bulky idea. The good idea is you must have certain kind of a machine learning AI kind of algorithm, so that we can if there is small even deviation, like here it is deviated from the center in this case, still it recognizes that yes, it is X. So this one is the concept building. So you understand it from here. I think it's everything is audible correctly till so far.
Yes, sir.
Okay, fine. So what we are doing here is we have some kind, you can see we have certain kind of signal which is here. Okay, and this one is basically you can see here it's a cardiac cycle basically. So it has different sections here, S1, S2, S3, whatever is there. So say we are not a medical expert, but as an engineer we know these are the signals. And now I want to identify. So what I will do is I'll take some kind of a features. Features means what is the important part of it. So for a signal, for this signal, feature can be its frequency, feature can be its amplitude, feature can be some correlations between the various peaks or something like that. So to be very simple, I'll take this input from this point and pass this input to the X0. X0 is say first neuron, okay, input. Okay, similarly I'll take another input from here, pass it here, another input here, pass it here, another input here, pass it here, and another input here, pass it here, something like this. So I'll pass these inputs to my neuron layer, and then these layers they give some value, and that value is taken further. So input is I have taken some kind of input which is basically signal, and I have given to X0, X1, X2, X3, X4. So these are the input layers. So once these values are given, so these values are basically they are input layers, you can see. So we have features, which is nothing but we have a certain kind of a waveform, and these are the inputs. So they are connected here, and this one is basically neural network here. Okay, and it will generate output. So output can be say binary. So you can say healthy or not healthy, something like that. Okay, so so what it is doing basically, this one is simple neural network. What it is doing, it is taking your cardio signal and then just giving the output that whether you are healthy or not healthy, or you have your some kind of other things which you want to design it. But let's say it's the simplest design is you are healthy or you are not healthy. So this one is fine, look fine to me, that okay, I take some inputs and then pass it to the neurons and process it in the neural network. We have mathematics of neural network, and then the output is healthy or not healthy. But I think it's not a very effective way. Reason being, when I talk about the signal, so it is not only that x0 is taken further. I can say that there is some kind of relation between x1 and x2. If I take here, there is some kind of relation between x2 and x3, some kind of this thing. Inputs are not like very, you can take the not your inputs are also there are some kind of a linking between them. So that's basically the next idea, that instead of taking directly to the input here, what we are taking, I'll take two inputs here, x1 and x2, pass to another layer here, another system, then again take x1 and x2, pass through another system, pass to, so something like that. So this one is basically, because what I'm thinking is not, x1 is not only important, x1 along with x2 is important, or similarly x2 with x3 is important. So we introduce something in between here, which is green color. We call this one as convolution layer. What is that? We'll explain it, but let's understand the concept here. So there are two things happening here. What are those two things? You can see here the number is your x0 to x8, and here 3, 3, 6, and we have another 8 here. So here one kind of a number is a reduction, but you can see here the inputs which are being processed here. Okay, they are basically linked information basically. So whenever I have series of informations or images there is some link between one vector or one column to the next column. It is not totally different, and then these are fed to my neural network to generate an output. So this one is a much better thought than the previous one for this kind of a problem. And then another thought comes in, why like this? Why like this? We can have some kind of more relation. So what is the mathematics here? You can just understand the mathematics here. So what is being done? These are the inputs, and each input is connected to here by somewhat certain weight. So you can say W8 here, W7 here, or something, W7 dash, W7, you can take double dash, 7 dash, W6 dash, double dash. So all these weights, X3 double dash, W3 double dash or W3 dash, all these are having certain weights. So what is the input to A? The input to A is the weight multiplied by this signal. So say I'm talking about this part. So what is the input here? Input here is your W7 double dash X7 plus W8 X8 plus some biasing. Biasing is presets, so some biasing. So these are the inputs to this, and then they are processed basically, pass through certain function. So you can say they pass through certain function. So pass through this function, and here the function is taken as sigmoidal function, which is denoted by sigma, and whatever the value generated here, then that value is passed through output. So this one is basically a concept here, nothing much as such very big here, that the weights multiplied by the inputs plus the bias, that will be the output of A, and then that output is directly connected to the output of A is connected to the output neuron. So we can see only this one and this one, only this and this. As in, this A layer is not visible to us. This one is basically somewhere in between. So this is how you can generate. So you can see here the output is this output, or any output, that this output, say if I talk about this output, depends upon the two inputs basically here. So one is the x1 and another. So every output depends upon two inputs or something. In earlier case, when A is not there, then there is some kind of all are mixed and they pass through it. So the another part is given. Then suggestion is that if we take three sets instead of taking two sets, if you take three sets, you can see here. So if you take three sets, then the results are much better because there may be more better relation and all that. So the interesting part here is you can see this input to the fully connected network. It is same basically 1, 2, 3, 4, 5, 6, 7. So you have some kind of reduction accordingly, and this one is the same network where these all are input and you will get output. But the interesting part here is now we have more correlation between the columns of this one. So if we go by like this, more connections and all that, so then what is happening in this structure? We have these three weights here, then three weights here, or something like that. So the weight increases and network look more complex to me. And if I increase the impact means if I take from x0 to x4 or x1 to x5, then it is almost similar to my first case, that is all are interconnected. And then again it become bulky. So what is the solution? The solution is like this. Solution is very interesting. Say, so there is no need of taking three here. What you do is you take these two, take A here, these two, take A here, and then again these two are combined and take another B. So this one is one convolution layer, this one is another convolution layer, and then you pass it to the F. So this one is nothing but like dividing the big picture into small segments. It is same here. So B is another convolution layer, and then you can pass the output of B to the network, and which will give the final results. So here you can see the things are very simple in the structure, and when the things are simple, then your complexity and the algorithm and processing will be much easier. So what is that? So what is this one? We can make it further simple then. Okay, let's make it further simple. How to make it? That is basically we introduce one more layer in between A and B. You can see here it is B, here it is A. We have introduced one more layer. Okay, this one is known as max pooling layer. What is the meaning of it? Let's understand the concept, then I'll explain with the example also. Max pooling layer means what is the maximum value between two. So if I'm taking this one as also input, what is this one as well? Which one is dominating? So if this one is dominating, I'll take that one for further consideration. If something is not dominating, I'll not consider it for further calculation. That is the meaning of the max pooling layer. But the interesting part is when you apply max pooling layer, the second convolution layer is only three elements, and you have a network there. So you can see that at the bottom you have how many inputs are there, and then as you progress it like this, you can see that the input to the network, fully connected network, is very less. So then this network will be very less. Earlier in the initial stage, this network is very big. You have 8 inputs or say 2 outputs, so you have all connected weights with each other. Now it is 3 inputs and only 2 outputs or 1 output. So the network become very simple. So what we are doing, we are doing all these calculations before feeding it to the fully connected network. This one is what I'm talking about so far as one dimension. What about if it is a 2-dimension picture? So things become very simple. You can see here, this one is one cell. So it has 4 parts, and then you have A's, then A's are connected. This one is the basic picture. Then you connect it to B's. So this structure is further reduced. And if you introduce max layer to it, then things become very simple. So you have inputs. That is basically inputs. Here you have convolution layer. Here you have max layer. Again a convolution layer, and then you can have outputs. So that is basically that is the concept of basically convolution neural network. And what is there in these A's can be like this, your simple network, or it can be a coupled network. That is your choice how you want to design it. What is the meaning of N0, N1, and all these things? Let me tell you. I'll explain you while solving one example. These are basically the job of this part is to identify, say, if I identify an image, it will identify x lines, x-axis lines. This will identify, say, y-axis lines. This one identifies, say, some curved lines, something like this. So they have particular job. They are not doing everything. So that is basically, these are the building blocks of your CNN. So finally, your big image, which is like this, after doing all processing, you can say the image reduces. So there are various networks and all these things. We will discuss some of them here, and let's solve by using one example. So I'm taking one example which is a very given in most of the books also. So say I have to identify x, and I have this image. So you can have this image. So wherever is the x, that is the black part, it is 1, and the rest part where it is not there, it is -1. So, and this I need to identify. I need to develop one algorithm to identify this x and 1 and -1. Okay, so you can see if you have some simple normal techniques, if you want to compare it, it will create a problem because this one is correct x, but this one is also x, but it is a deformed x. So the result will end up with something wrong, which is not good. So let's see how this algorithm will help us. So instead of comparing, the idea is instead of taking whole picture comparison, something we take a small part basically. Okay, so if I take only this part and I'll see where it is there, and if it is there, so I can say, okay, this part is matching with this one. Small parts I'm taking, so I take another part which is there, and then I compare it here in this image also. Okay, this part is not matching and something like that, and then I'll go for some kind of voting and all these things. So I compare small parts instead of comparing the whole image as such. Okay, so so let's go for example. So what is, we take on some features out of it. So you can say there I have drawn here one block here, another block here, okay, and third block is here, and fourth block is here, and you can have 5 blocks. But if you watch it carefully, this one is one block, you can see here. So this one is one block, which is number 1, and this is same at number 4 also. Okay, so this block can do the job of 1 and 4. Similarly, I have taken this one is another block, okay, which is block number 3, and then another block which is block number which represent block 2 and block 5. So if I take only these 3 blocks for this complete image and then try to find out whether these blocks are available in the another image, I can say in one form or another that yes, it is X. This is something interesting, and the arrangement I have also to see. So what we are doing, instead of comparing the whole image, we are just taking the 3 blocks of it, and then we try to compare those things. Okay, so the first layer is the convolution layer. Let's understand what is convolution layer. Convolution layer is basically this one is nothing new as such. This one is a mathematics. Basically, we studied somewhere during our undergrad also, that we use some kind of a transformation matrices or transformation setups, so that one form can be represented in some another form. So that is basically convolution, and there is a relation between one form to the another form. So the interesting is here how we put it. So here how we put it, let's solve one example. Before jumping to that, images, when you talk about images, this one is very commonly used, that is filters are there. So what is a filter? You can understand it. So if I have this image, okay, you can see this is the image. So if you take its pixel representation, you can easily identify that, okay, this is the image, because you can see that these are pixel values are 30, rest are zeros. So this one is basically identifying this part only. Okay, and then we can find it out where this image lie in this complete image. Okay, so it can match it. Okay, it can match here. Okay, this one is here somewhere here, something like that. So this one is basically filter, means that particular setup you embed, check it on the whole complete image one by putting it at various places, and try to find out whether that particular shape is available in that or not. So that is basically again the matching of the numbers, but on the smaller scale, something like that. So what is the convolution layer? So this one is basically one filter we have taken. Filter means this block, this section. I want to see where it is lying. So that is a filter. So I have taken this filter. Now let's understand its mathematics. Okay. So I have taken this one as a filter whose diagonal elements are 1, and then non-diagonal elements or other elements are -1. And then I put it here. I place it here. So this filter, people call it filter, some call it neurons, some it kernels. These are the various names used. I put it here on this one, and just I multiply LE point to point. So I multiply this one with this one. The result is 1, so I put it 1 here. Okay. So when I put it complete here, you will find that all are 1. See, 1 into 1 minus 1 into minus 1 is again 1. It's 1, 1, 1, and then I divide it by the whole. So the result will be 1. So when I put it this one on this one, the output result is like this. All are 1. So the output final result is 1. So that is to understand it, whether that means what? It is completely matching it here. Very simple process. It is completely matching it here. But if I put it somewhere else, then it will not completely match. So what I do is I represent this whole image like this. Okay, at the center it is 1, and I leave it. If I take this image somewhere here, the same filter I put it here. Okay, so you can see here that filter was like what was the filter? Filter was 1, 1, 1, minus 1, minus 1, minus 1, minus 1, minus 1, minus. So if I put this over this, you will find it will not 1. It will come as 0.55. Okay, so what will be happening if I do it for all? You will find your matrices is something different. The matrix will become like this. Will the matrix you will obtain if you put the filter throughout the image. Okay, so I'll take this filter, put it here, calculate the value, then shift it here, calculate the value, then shift to the next, calculate the value, and I convert it like this. Okay, so what is happening here, by doing this approach, simple approach, your 9 cross 9 matrix is reduces to 7 cross 7 matrix. You'll find very interesting trick. These are the tricks basically, nothing more than that. So 9 cross 9 is reduces to your 7 cross 7 matrix. So this one is the what convolution is doing basically. So convolution is converting one kind of matrix to another kind with the reductions in the size of that. Okay, so what we do is we take 3 filters. Okay, so one filter is this one. I implement it here, I'll get this. Another filter here, I implement on this, I'll get this image. Okay, all these are 7 cross 7 images, and I take this filter, put it here, I'll get this 7 cross 7. So this one is the convolution layer output. So I have taken 3 filters, put on the image, and the output of A is something like this. Now, if you remember the yeah.
Hello, sir.
Yes.
Sorry to interrupt you. Okay. So here in Maharashtra there is a cyclone today. Okay. So I request all the participants that there may be disconnection may happen in between. Okay. So don't be impatient if the disconnection is there. Okay. Don't be impatient if the disconnection is there due to the cyclone. We will resume if there is any disconnection soon. Okay. If the disconnection is occurred, then we will mail to you. Okay. And probably disconnection will not be occur. Suppose disconnection is occur, then please be patient with us. Thank you, sir.
Okay. Fine. So so what we are doing is okay, I think it's clearly audible and visible, right?
Yes, sir, it is audible and visible.
Hello.
Yeah. Okay,
Rajesh,
fine. So yeah, hello. Okay, so so now this one is basically we have implemented and we have output, but you see the output of the convolution layer pass through certain kind of a function. Okay, so that is basically known as activation function. So there are various types of functions. You can have sigmoidal function, you can have tangential function, you have some kind of linear. So there is basically here we are talking about ReLU layer. ReLU layer is nothing but linear activation function. So this function is like this. We call it rectified linear unit, ReLU, ReLU. So rectified linear unit, and the unit is the function expression is for till 0 it is 0, and after that it is linearly increasing. So the question is very obvious, why we are taking such kind of activation function. So for that I suggest you while training the network, updating the weights, we have to, the most common approach is taking backpropagation technique. So what we do in that, we take the gradient of the my loss function, and based upon that I'll modify my weights. So what happens while taking gradient, sometimes my functions are like that. When you take the gradient of a function, either we reach to non-differential form, or the gradient is not proper, and that will create a problem. Here you can see the gradient is a constant, so that is a good part here which help us. Then another good part is basically it filter out negative values. So because they are of no use for me, so I can take the values which are negative, make them 0. Things becomes very simple. Because otherwise what will happen, some values are negative and some are positive, and when we sum up all those things, they will end up with 0, output as 0, which is not a correct information. So what we do is we remove the negative part, so we left with only the positive values. Okay, so if we sum them up, they will never go to 0, something like that. So this one is basically ReLU function. What it is doing, you can see here, we pass any value through it. If it is negative, it becomes 0. If it is positive, it remains as positive, same way. Okay, so same thing. Now this one is 7x7 matrix, which I obtained after the convolution filter. Now I pass through the ReLU function, which is, see the notation like this. So you can see the positive value remains there, and the negative value, all values become 0. So that's an interesting part here. So now I have two things with me. Okay, only the positive values and the zeros are there. So that is the complete output of your activation complete function. Now we go for the max layer. Okay, so this value is just so max layer is basically a pooling layer. Okay, and I told you in the max layer that you compare to the signals and find out the max. So same we'll do it here. Let's understand it. Okay, so I just move directly to the example. So say if I take to take this function as here, I'll take a size of 2 by 2. This one is a window, so I have to move everywhere. Now this one is very interesting, that okay, what should be the size of window and all that. I'm not going to that because that take more of time. That's an interesting area. People are doing work on that also. So what is the maximum value of these 4 values? It is 1, so I put it 1 here. Then I move the window, and then again it's a very interesting area of research also, how much I have to move. So let's go by one step. I'll put it here. So everywhere, so what is the maximum here in this one? It is 1, so I put it here. Then what is the maximum here? It is 0.33, I put it here. What is the maximum here? So I put it like this. And then this one is the last part is left, that we call it padding and all that. So I'm just keeping it here. You can move like this also. You can move your window like this also, overlapping also. This also you can do. Totally depends upon how you want to move in. Okay, so when you do it, and just what is the calculation you need to do? Find out what is the maximum value in that matrix. So this 7 is reduced to 4x4, and the information is still stored there. Information is not like, no, it is not deteriorated, or it is not gone. It is still there. So it is reduced to 4x4, and that's the interesting part here. So what we have done, we have these 3 after processing through the ReLU function, all positive and 1, and then we apply a max full maxing. So we have 3 of reduced size. 7 cross 7 is now reduced to 4 cross 4. So initially it was 9 cross 9. And what now you can play with, you can do it like this. So this one is basically actually what we have done so far, original image, and then we apply the convolution. So convolution convert into this 9 cross 9 to 7 cross 7, then apply ReLU, it will make it a positive. Then we apply pooling, which convert into 4 cross 4, you can see at the end. Okay, and now what you do is you repeat it. So you do it, this one is 9 cross 9, and then convolution, ReLU, pooling. Again you apply convolution, ReLU, pooling. You will see it will be nothing but 2 by 2 matrix now. So the big size of matrix is reduced to 2 by 2 size of matrix. So I have taken 2 sets, basically 2 sets of my my approach. Convolution, ReLU, pooling. Again I repeat it. So the 9 cross 9 matrix is reduced to 2 by 2, and which is now easy to handle. Now this I pass it to the fully connected network. So what I'll do, I'll pass it to the fully connected network. So fully connected is just I arrange this one into a simple vector. Okay. So this one is the vector. So this one is the first part which I have put it there, and then this one is the second part, and this one is third part. So my vector, input vector, is basically nothing but 1, 2, 3, 4, and there are 3 sets. So there are 12 values which are going to my neural network and generating one output. So you can see here, this one is for X and this one is for O, and that's all. Now that's everything is done. Now it's basically to estimate and all these things. So how it will work, let's take it how it will work. So you can see there are certain features which are high here, they represent X, and you can see those who are representing O, they are different than X. So that means the two images can be easily classified, they can be identified properly. Okay, so let's take any random image, and then we check it whether this one is X or this one is representing O. Okay, so what we do, we take this image, okay, and first we compare. This image is nothing but this one is 12 value vector, and I compare it to a 12 value vector of X, my standard one, trained one. So what I'll do, I just compare it. Okay, and what I'll take is I'll take the highest values. Okay, and then sum the highest values. Okay, and the value is 4.56. Okay, or you can say the corresponding values. So first value here, or this one, or this one, likewise. I just find out what are the values and I just sum it up. It will come 4.56. Here the value is 5. So I just divide it. It will give me a probability of matching or something like this, 0.91 or 91%, similar kind of stuff. Okay, and then I take the zeros. Okay, so I'll compare where the zeros are 1, and I take these values from here and just I calculate it. What is the sum divided by the 4? It will come 0.51. So which one is more? Your X is more. So we can say the new image is X. That's a simple process now. Now think very simple. Instead of taking too much big architecture, so many say weight updation, 1,20,000 weights to updated. Every weight updation is basically done through back propagation with a lot of derivatives and those terms. These things are very simple. We don't have anything big in it as such, and we can easily classify the images. So where there is more nearness, that image can be classified like that. So you can see here, this one is not exactly 1. Exactly 1 has to be, this value has to be 1, because then it has to be 5 by 5, but it is near to 1. So this one is basically approach to be adopted to find out how CNN works. So the process is very simple to implement CNN. What you take an image, and then if the image signals are there with you, go for the convolution. then after that go for the ReLU function approach, and then go for max pooling and see how much it is the reduction. Again go for it till it reduces a very small size, and then connect it to a fully network, and then your system is ready, train it. Finally you have a CNN classifier. So this one is something like, so many images are being taken, images of dogs, and they are put it here, they are used to train this neural network. And when you give a new image from a new data set, it correctly identifies that this one is a dog or not. So few of the applications at my lab I'll discuss with you, and then some power applications also we can discuss. So I think we have time. Yeah. So one of them, is the process or the pipeline is clear to you, that how your CNN works?
Sir.
Okay, I'll take the question.
Yes, sir.
I'll take the question at the end. Yeah. Okay, fine. So the first one is the what we are doing at our this one is Raman lab, is my lab. So that is basically face detection. So just taking the features and then try to identify about person, that okay, this is that particular person. So that is basically, even you can take a deformed images also, like some changes you have created using some apps, and can you still identify the person correctly or not. This one is so these are many of them are identification kind of testing. This one is second thing, which is cancer detection. We have cell images, and from the cell images we can find out the location and the size of the tumor, and even we can find out from the images whether it's a cancerous or not. So this one is another application which is being used there. This one is basically brain computer brain machine interface. You can see brain signals are taken from outside, nothing is inside the body, the cap is there, so we take image signals from there, and then those signals are basically taken here, connected to the computer here interface, and then this computer is being used to move this vehicle basically. So that is how you can, people who are having paralysis and all that, they can use it. So another application of this one, so this one the same cap, long back taken, and you can have these images basically. These are the signals which are being taken from each sensor nodes. So these are the signals. You can see now the signals are there. These are nothing but, for me it is a you can say 2D image or 1D image, whatever you say accordingly, and then these are processed to identify the IQ level of person. So you can very clearly identify that what is the IQ level of these two and what is the IQ level of these 3 and 4 persons. So multiple applications are there. So this one is another work being done, and then this one is CGHR detection. I don't know if this video works fine. So you can see these are the, you can see here the signals are there. Some of my student, he worked on it. We developed this part, and these signals are basically directly connected to brain thermal mapping kind of structure, and from there you can apply these approaches to find out what the researchers are doing is try to find out what is the origin point of the that particular pain and those structures and all that things. So this one is another work which is being used. This one is very interesting domain, and we are still working. One part we have already done. We are working on the second part, that is gate analysis. Those who are interested in computer science, this one is very important. Another area of security basically. Your gate are unique, so you cannot copy anybody's gate. Gate means the way you move from one point to another point. So your walking pattern is your gate. So it is unique for everybody. So that is one work. This one is lab photographs. We have put 4 cameras and tried capture the images, make the video how a person moves. You can see here, and they are taken from different angles, and then we try to find out the gate signatures out of it. So what is being done? A person is there, he is asked to move. So movie is divided into various frames. These are the images, and then the images are cropped and remove some noise and filtering and some kind of image processing technique, and then their coordinates are basically identified. You can see their coordinate at neck, hip, knee, and ankle. So these coordinates are generated, and from these coordinates we have complete signatures, and these are the unique signatures. And then these signatures are compared with the benchmarks. Some interesting research is going on. You can predict various medical things from your gate signatures, like very recent some recent work is there, like we can predict even person will be diabetic or not using gate signatures. So something like hidden health agendas, they are still there. Gate is very common in sports and all that, because there it can give you some kind of indication that okay, whether the way you are running or whether the way you are doing the exercise, is it correct or not. If it is not correct, being used in cricket also, like the action is correct or not. So then it will give you some kind of prediction also, that if you don't rectify it, then in future you may have this kind of problem, maybe back problem or ankle problem or thigh problem, something like that. So there are n number of applications for such type of things. You just take one part, means you need to focus on the type of thing you want to address it. If you have data, then you can label it, you can apply these machine learning techniques to automate, detect the things and all those stuffs there. So I think this, I can show you this video. So this one is the one of the program developed by my PhD scholar in the same gate. So you can see it here. It will give you an idea that how it works. So it's loading some already image file there. So you can see here, this one is lab environment. You can see a lot of obstacles are already there. A lot of other gates, doors, and everything is there, and everything is all the blank, all the inputs are. Now the person enter, and you can see the graph starts coming in. You can have a trunk angle here, hip angle here, knee angle, ankle angle, thigh angle, leg angle, foot, heel strike, and all these things. And when it complete, it will give the complete signature of you. So this one is basically a signature, your own signature, and you can find out various things. Okay, what does that mean? So now these signatures can be compared with the benchmarks, and then you can identify various issues related to health or security or anything, whatever you want to use. So this one is another area where you can implement those things. One student is working on this one, knee arthritis. So you will find more of healthcare here, but towards the end I'll talk on some kind of electrical, pure electrical also. So why this one? This one is very important. Like knee arthritis, almost nowadays technically, if we go after the age of 45, everybody is suffering from knee problems basically. So how to identify these things without going for going for some kind of inner kind of structure. So the thought process is something different here. You put sensors on the body rather than taking internal images, and from there we try to find it out what is happening. So that is one kind of work which being done. Now let's coming to the electrical, because there are a lot of healthcare we are doing. Now electrical is something, this one is very interesting. You can see here that there is a grid which is here. We have DG source which is here. This one is point of common coupling where your microgrid is connected, and you have load. So this one is, if your switch is open, then this one is islanded. Islanded means self-sustained mode, and if switch is closed, then it will take power from this side and to supply this one. Otherwise it will supply from this one. So the issue here is if the islanding is known to us, then it's okay, no an issue. But if islanding is unknown, in that case there is a malfunction of relays and protection devices, and it may lead to some kind of it will lead to some kind of a problem to the person who are maintaining it and all these things. So while developing it, what we have, and another issue is there, because here we have inverter is there. So what is this inverter is doing? So here it is, say solar, this one is AC, and here is one kind of the stuff which is converting it power to here. So what it is there, inverter, if it is open, then takes this one and then supply like this, and if it is closed, then the supply direction is this one. In both the if the switch is open or if the switch is closed, in that scenario the inverter has to change its mode of operation. Otherwise, what will happen? It will create a problem to at a bigger level. So normally the people have adopted some technique. They put some sensors at remote area, and from there they are sensing it and the passing it. The hypothesis we proposed here is that like inspired from your medical signal. And what the hypothesis we proposed here is that okay, your signals which are there, current signals or voltage signals, they have some kind of information what is going to happen. So can we predict it fast and all that? Okay, so we have done different approach, but yeah, CNN can be applied because I have this my current or voltage signal like this form. So this one is again the voice signal, which we have taken as our reference example, and then it can be taken applied to kind of a CNN structure to identify what is going to happen. And then you can place it into the inverter itself because it's not a big, it's a small one can say, small size image or structure. So you can burn it or you can pass the code to some kind of a Raspberry kind of device and put it inside the inverter so that it automatically detect and change the mode of operation, and that makes your inverter as an intelligent inverter. So that is another kind of application which can be used for this purpose. The robotics is full of all these things. So we developed some kind of eyes here, and there we have applied these approaches. So we have mixed with CNN and all these stuff with reinforcement learning and all that stuff. The videos is still there. You can see the video, small part of it. You can see it is detecting the objects basically. Okay, so it is detecting and taking the differences. Now the point is, you can say, sir, it may have some kind of a sensors, proximity sensor. So as soon as it reach near to the obstacle, it automatically take a left, right. No. Here the concept is different. You can see here we have taken 2 cameras. The idea is to develop a complete eye of it and the brain of it, and everything is done on the basis of the image processing and all that. So this one is another work which is being done there. So robotics full of it. Motion planning you can do. You can take a map of a city, okay, with some kind of stamping, time stamping, and it keep on updating on your device. So it keep on giving you an idea. You can have various types of different types of image processing approaches or machine learning approaches to find out which is the best route, which is having a less traffic, and you can reach fast. Or if the traffic is there, more fuel consumption will be there, so which is the best route to reduce your fuel consumptions and all that. Various kind of techniques can be used there. Biometrics is another area where you can go for the security or applications. So not only the security, you can see here emotion detection, retina detection, eye quality detection, one can say what is we call it, focal length issues and all that. So those things can be detected. Okay, body language detection, facial detections. Even nowadays, people are trying to connect it with the attacks and theft and all these things. So this one is basically to completely to civil engineering. You have satellite images, and from that images you can go for vegetation detection, damage detection, okay, oil detection, and then something like as announced, there is a cyclone or there's an earthquake or something like that. So there's these are the few areas where civil engineering and we are combined to work on. These are the object identification. What are the various objects in an image? So they may help to develop your devices more and more smarter. So this one is another area where you can apply the CNN. This one is some electrical part because I'm just skipping those ones. What we are those earlier one because those are more of health issues. So you can see here, this one is nothing but I'm having a time series data. You can see here, this one is time series data. And what is this time series data? Okay, let's say this one is a wind. It can be a solar, it can be a load. Okay, it can be a voltage profile, it can be a current profile. So it's related to your power system. It can be your EV, it can be your battery. So this one is basically time series data. Okay, and you can see here I'm taking a window here. So I'm taking this window. Okay, this window is taken as an image here. Okay, so what I'll do, I reduce the features of this one. So this one is, these are the inputs. This one is taken as input. I reduce it by using using some kind of stuff. Or what I'll do, I'll take this one as a one image, pass it here, use some kind of a convolution layers, reduce it, and pass it to the fully connected here. This one is fully connected, and then identify. Okay, okay. Then I'll from here I'll identify. Now identification can be one. Earlier we have done is classification, that whether it is X or whether it is O, or whether it's healthy or not healthy. That's a classification. Here we can go for the identify. We can go for kind of prediction basically. So what we can have is we divide the data in two parts, say till here. So this data I can use it to train, and then this data I can use to test. Then next sample, last sample, if I pass it, it will give me the prediction of the last sample. So it is something like that. Okay, I have this data. Okay, so I take it. This one is I do it for training, and then I can this data, till this point I have data. This one is I clean it up a bit. So if I have data like this, so I use it for training and train, and this I do it for testing. So if it is accurate, now what I'll do, I'll predict what is the next. Okay, so I'll say next will be like this. Okay, but in actual the next is something like this. I can take this gap and then further modify, again redo the things, and then I use it, modify it, then at this instant again I predict it, and again I'll get the actual one and keep on doing like this. So this one is a very interesting application. Very less papers are being published in that one. That predicting all these things using some kind of a CNN based approach, because see, it's a prediction can be done with a lot of approaches. You can have basic regression models, then you can have simple neural network, then you have deep connected neural networks, and likewise. So various approaches. This can be also one of the approaches which can be used there. And then another very interesting approach which can be taken is this one. So this one is basically you can have, this one is 13-bus system, those who are from power system, and from here I have this matrix which is basically your y matrix. Okay, so I can convert into like this y matrix, and then I use a certain kind of filter over it which give me convolution. So this completed big matrix can be converted like this. Okay, and then I do some kind of max pooling which is further reduced like this, and then it passes to the fully connected network which give me the output. Now this can be used for various purposes. It can be used for the your system security, power system security. It can be used for your power system stability analysis. It can be used for some kind of behavior response of your power system. But you see the concept is being there. I'm not taking any image as such here now. You can see here. This one I found in a very good IEEE transaction paper, that this one is very interesting to see that how you take a big picture. This one is 13 bus. You can have a 1/3 bigger system, 100+ kind of system. So the matrix will be big. Then you use some kind of a filter which convolute your big matrix to the small. Then you go for further small, and then pass this one to the neural network, which identify the things very fast. See, if my neural network is simple in the structure, then I can say yes, now it can be implemented online kind of stuff and all that. Otherwise, if my network is big, it has its own processing time, and then it's difficult to say that it is working on the real-time kind of frame and all that. So this one is another application to power system problem, that this one is applicable to any signal prediction. You can apply it. any type of signal you can have, from medical science to your power system, any kind of signal. So I think I'll end up here, and I think before ending, I thank all the researchers who put various informations at various platforms so that people can use it. So I think I am able to make the thing clear, what is CNN. It's not very, the name is very look different for electrical engineers, but it's a very simple way of processing, making your big structure to a small structures and then using it, and some applications which we have done. So now I'm open for the queries from your side. So either you write on the chat and then I'll answer your queries, or the way you want to do it. Thank you very much from my side. I'm ready to take some questions if you have.
Yeah, sir. We have some questions over here. Hello. Are you able to
Yes.
listen?
Yeah, I can listen.
Hello.
Yes.
Yeah.
Audible.
Yeah, sir. There are some questions from the participants. I will ask one by one. Okay. There is one question from Avinash Welliver, that can we use CNN for electrical fault signature detection?
Yes, you can use it because I have signatures. Okay, you can use it. The only thing we need to understand is we need to do some experiment parties or the convolution windows and all that part. That's all. You can use it. It's interesting to see if you implement this approach for your fault detection. Because see, the last slide which I have shown you, it is nothing but it's a dimension reduction of your impedance matrix of your 13-bus system using on the similar framework. So you can use it. It's and let's see if you can use it. What type of results you are getting.
Okay, sir. One more question from Sudhir Patil. Can we implement biometric system for electrical?
Biometrics for the security of electric vehicle. Yes, not an issue, because electric for your instead of key, you replace your electric vehicle on off, ignition on, ignition off, door lock, and everything on the basis of your biometrics. Not an issue.
Okay. The next question is from Mr. Jagdish Pawar. Convolution neural network have a different architecture than the regular neural network. Regular neural network transform an input by putting it through a series of hidden layers. Every layer is made up of set of neurons, where each layer is fully connected to all neurons in the layer before. Okay. So where each layer is connected to all neurons, the layer before.
Yeah, see, in convolution, that's why, see, in neural network, that's why the weights we need to train is something like 1,20,000, because each layer is connected to each other and each neuron is connected to each other. So all the weights I need to update while training. Here it is not like that. Here it is not like that. I need not to train because my network is not fully connected. Only the last part is fully connected, where the inputs are very less, and it is simple. There is no hidden layer there, only the input layer and the output layer. So the connections, the weights are very less. So the whole system becomes very light to work on.
Yes, sir. Thank you, sir. The next question is from Vinod Kumar, sir. Once we get input after feature instruction, what is the procedure for convoluting the inputs, or we just randomly connect inputs in convolution layer?
No. See, I have inputs. So inputs are there. Then the convolution layer, what it is doing basically, I have certain kind of filters. Okay, So those filters is you are extracting those things. So if you have already some features which are obtained, so what you can do is you can skip that layer, and you can jump directly to your ReLU, and then your what we can say the last max pooling. But still the architecture is big. Then you need again convolution, because you don't know what is the filter you are using. Now filter here in this case I have taken a 3x3 matrix. Your filters can be something some other numbers also, like mean value, more than mean, less than mean. Those are the basically to extract features means like na whole thing I want to make it less. That's the important part. So you can have different types of convolution is the same thing. What we are reducing the dimensions or the features in a organized manner. It is not just like that.
Okay, sir. Thank you, sir. One more question is from Rashmi, madam.
Yeah.
Sir, how to decide whether to take the adjacent window or overlapping window, and what is the effect of size of window on output?
Right. So this one is a very important aspect, because see, if I take one aspect is, if I take a window size very small, then my reduction in the size is less. Okay. So, and if I take a very big window, then my image is just like that only. So that is one thing. Second part is there that, okay, say my vectors, vertical vectors are say in odd number, and I choose my window size E1 and passing with each other. So what will happen? The last vector remain as it is. So what to do? So, and if I take odd, it may be possible that odd number also remain there. Say if it is vector of 10 and I take a size of 4. So 4 and then 4, 8, then 2 remain there. So these are the certain issues there. Number one. Number two is, in that case we need to do overlapping. So or there are other methods like padding and all these things. These are standardized methods which are not very new here. Another thing is it is matrix of data. Many times we are not sure enough that, okay, the convolution window which we are moving, if it is shifted in a very proper way, then what will happen is, then the features what we are looking for, or the hidden features which are there, though they are important, they come out very properly. Say one is frequency. So if my window size is big enough and it is not able to hit that frequency part, so I may miss the important information out of it. So that's why what many of people, what they do is, one way is they try to do different windowing, sizing and overlapping. Some people make it further automated. Okay, so that you can do it, like you can take it as optimization problem, that what is the optimal size of a window, okay, and what is the optimal overlapping, and then you can use some optimization technique to find out what is the optimal size and overlapping for your problem. So it can be converted to optimization problem and can be solved that. Other way, there are some theoretical ways are already given in the almost most of the books, that how much overlapping is there, if there is something left at the end, how the padding is being done, what is the effect of padding and all those things. So those things can be taken from there. But it's a very it has to be analyzed, that, okay, why I have taken a size of 3x3, why not 2x2, what will happen if I take 4x4, and if it is 4x4, what will happen if I taking no any overlapping, or 50% overlapping, or 20% overlapping, or something like that.
Yes.
So this one is that, and that varies from problem to problem. It's not like,
Yes.
no, it's universal. It
So
varies from problem to problem.
we have a one more couple of questions. Is online feature extraction is online feature extraction for frequency estimation is possible? If yes,
Yeah, it is possible. Yeah.
what would be the minimum size of samples? This is question from Arpit Kumar Patel, sir.
Yeah. See, when I say it's a online working, so two things are very important. number one is how I define online. What is my sample time, sampling time? So say if my sampling time is 1 millisecond. Okay, so next data I need after 1 millisecond, or predicted value after 1 millisecond. So if my algorithm is good enough to find out my outputs within 1 millisecond, I can say it's online. For some problem, say it is say 1 hour or say 2 hour, so I'll call it because I'll collect my data after every 2 hour, and I need the prediction of what will happen after 2 hour. So what in that case your algorithm has to give your results within 2 hours. Okay, so that totally depends upon your time period, how much time period you are giving your algorithm to predict, and how much time is you are collecting your samples data. So that is basically online. It is not like a kind of a thing. Now if in some applications what we do, my instance are say in microseconds, and my algorithm is generating a result in some say milliseconds, then it's not online, because by the time my algorithm give me a result, by that time my actual process is much ahead of it. So that is not a kind of online. So if you're looking for an online, you need to understand the time span, in which you want to generate your results. And if your window is less, window means the time span is less, then your algorithm has to be so light that it will generate the result within that period. If you are able to do so, you can say yes, I am working on online system.
One more question is from Goel Agwan sir. Can we apply the CNN to identify the most sensitive bus in the microgrid model so that we can apply the CT and PT at appropriate location?
Yeah, it's again identification problem. Okay, so there we need to see the architecture of my structure. Okay, if my network is big or my variables are heavy, and I suggested this one for all kind of machine learning and all these problems. If my problem is complex and bulky, then okay, we have to jump into it. But if it is a simple single wire problem, why should I apply it? I know if the wire is broken, there is no any current on the other side, so there is no need of applying machine learning or all these stuff. But yeah, if it is a mesh of wire where it is difficult for me to identify what is happening where, yes, I can jump to it.
Okay, sir. Thank you for your very nice session. On the behalf of Department of Electrical Engineering, KKWIEER Education Society, KKWIEER Institute of Engineering Education and Research, Nashik, I would like to thank you, Dr. Rajesh Kumar sir, for a nice session on the application of ANN. Okay, so from the basic to application level. Okay, so hope you have enjoyed the session today. Thank you very much, sir. Once again, from all the participants and from my institute, I would like to thank you.
Yeah, thank you very much. Thanks for listening me. Thanks a lot.
Yes, sir, thank you. And next section we have Dr. V.A. Kalkamkar, who is the PhD student of Dr. Rajesh Kumar sir, and he has implemented some algorithm in his PhD. So in the next session we will start at the 1 p.m. Okay, exact sharp at 1 p.m. So Dr. V.A. Kalkamkar will be the presenter for the next session. Thank you. Now it is a break time up to 1 p.m.